Hi, everyone. Welcome to today's webinar. Super excited to have all of you today. My name is Kennedy Torkura. I'm one of the founders here at Mitigant and also the CTO. A little bit about Mitigant. We are a cloud security startup. We are based in Germany. And yeah, we do cloud security, different kinds of cloud security. And we always have webinars from time to time, at least once in a month, where we speak or let's say address very important or exciting topics like what we're going to be talking about today. Yeah, so for today's webinar, basically we have the recording on, so we're going to be recording the session, and it's going to be about 45 minutes or so, and then we're going to have an interactive session after about 45 minutes. At that time, we're not recording again. For today's webinar, we are going to be looking at the role of research in cloud security. It's a very exciting topic. I personally am very much have it at the top of my heart. It's something I really love doing research. And we are pretty lucky to have in our midst our guest speaker, Christophe Parisel. And I believe that most of us in the audience, we probably most of, we know Christophe. If you are someone who is passionate about cloud security or you follow this topic, you must have encountered either his post on LinkedIn or his writings. He also has a blog article. A blog post where he talks a lot. A post about a lot of topics. Without much ado, I would like to basically invite Christophe to the floor. Hi, Christophe.
Hello, thank you, Kennedy. Thank you so much for inviting me and for hosting that event. I really appreciate because as yourself, I'm really passionate about cloud security, and I think that we have a lot of points in common, I would say, even if our backgrounds are very different. We have many common motivations and lots of experience to tell about research and innovation in the cloud that we've been pursuing for many years now. So really excited to participate, and thanks again for inviting me. Thanks a lot.
Yeah, no worries. Yeah, I know we have a lot of things in common, and we've been interacting in different ways over the years, and we decided to kind of bring out talk about stuff in the public here. And
Yes, you're
so
right. Yes, it's the first time we speak together publicly, so I'm really
yeah.
enjoying and looking forward to that event, Kennedy, because it's been. I think we should have done that already many years ago, since we have so many points in commons. I think so. Thanks. That's very interesting.
Yeah, it's never late, right? So maybe let's start with just talking a little bit about our backgrounds, because pretty much and I know people in the audience will be curious to kind of understand, our background, what we've done in the past, and what led to where we are, what motivates us. So Christophe, do you want to start to like say a few words about your
Right.
background?
Yes. Okay. So thanks. I am a cloud security architect, and I've specialized in Azure over time. I started to work in cloud security about 10 years ago now, in 2015. Before that, I was doing a lot of security related stuff in architecture, pen testing, lots of different areas of security. But I really dedicated my time, I would say, to cloud security 10 years ago, when there was many things to do, as we will probably discuss, to understand how the general landscape of cloud security. And I'm still in the field of cloud security, especially in Asia. And I have recently, like many of you guys, enlarged my scope of activity to AI. And I think that's one of the subjects that we will discuss, because Kennedy also enlarged his experience and his expertise in that domain.
Yeah, thank you so much. So, I mean, I remember that I think the cloud has been around for slightly over a decade, and people initially were not really wanting to adopt the cloud. After some time, when they saw success stories of like Netflix and some other companies, then people kind of got the confidence. They started adopting the cloud, and now we have seen massive, let's say, mass adoption. COVID came, and even those who didn't want to adopt just jump in, and we've seen the cloud basically disrupting virtually every technology that we have out there. So it's pretty exciting that and that you kind of focus on the cloud and especially Azure to kind of bring out research and all of that. Um, probably just talking about and I will just give after you talk, I will also give an introduction to my grant. I wanted to ask in terms of like the transition from the like on premises or what you were doing before to the cloud, and the role of research in this translation. Is it something you can kind of talk a little bit about so that we can understand?
Yes, sure. Yes, no problem. When well, a decade ago, the cloud was really, I would say, very in its infancy in terms of security. So, well, when I had to work on the mass migration of application into the cloud, it was like a shock for me, a cultural shock. Um, because we what we used to do on premises it's very was at least very different from the capabilities of the cloud at the time. We well you it depends on the industries, but at least in the banking industry we have a huge culture of preventive security, even if we do a lot of detection as well. But preventive is something that we try to do as much as we can, and it's both easy and difficult on premises. It's easy because we are our own masters. We can decide of what we want to do in terms of control, in terms of services and security feature that we want or we don't want to enable. It's also difficult because we have a huge legacy, a huge culture of processes which are, of course, a lot of very human-centric and very difficult, I would say, to change overnight. We were in this lack of state of mind, trying to run our controls preventively to save costs, while at the same time being aware that it was a difficult transformation. But this is something that we were trying to do as much as possible. And then when we switched to the cloud, we immediately saw the opportunity of automation. Automation in the cloud, of course, is very, it's key, as everybody knows. But for me, it's especially key because we have two very important things that are interesting for security. First is infrastructure code and the REST APIs, meaning that we can deploy workload and configure workloads programmatically using APIs and using infrastructure as code, something that's very difficult to achieve on premises because of all the technical depth that we have. And it's all streamlined and unified, very simple in the cloud. And on the other side of the spectrum, let's say, of the life cycle, we have logs. And these logs are also very homogeneous, uniform, consistent. And in between the logs and the API, we have the CMDB. The CMDB is the real life state of all your assets, which is always accurate, always up to date, in real time. And leveraging on these three assets, I think it's something that was a huge, and it's still a huge opportunity for building secure systems in the cloud, even if at the beginning it was not the case at all. Of course, we will get back to this, I guess.
Wow, that's really awesome. I mean, this what you mentioned is I think it's like the how would I call it? It's like the on the one hand, the cloud it's like two sides from a security standpoint. It's challenging. Most people actually see the challenging part, and yes, it's challenging. But these four aspects you talked about, which is automation, API logs, and CMDB, it's kind of the let's say the gold part for defenders. If you basically can wrap your head around how these things work and how you can use them, all of a sudden you realize that it's kind of easier, and the cloud is a blessing from a security standpoint. And I would say that that was kind of that was my own realization also. These things you mentioned. So I personally more like I got into the cloud and the cloud security, cloud research from academic research, like from academia, and starting from my masters. I just this was the early days of the cloud, and we had a bunch of assignments around cloud. Then cloud was like the way, in terms of hype, the way AI is being hyped now. So it was like very being hyped, a hyped topic. So I just got interested and did my master's thesis around cloud security. And then from there, I just continued for a doctorate program. And it was always very interesting. I had the opportunity actually to more like look at cloud from like playing around with OpenStack, which incidentally has been the only open source cloud software till date. But playing with it actually gave me a very good understanding of the underlying, all the moving parts, all of these logs, the API, how powerful they can be. And for me, that was like an eye opener. And fast forward, I also got a chance to like work in a company as a cloud security researcher. And for me, the moment when I saw the advert, the job description, that was really like, wow, you mean someone can actually employ you to be officially just doing research? It was really like, man, this is really, really good. And that basically gave me like two different kinds of different experiences, from from the academic research standpoint to the side of doing it in a company as an employee, and looking at the expectations of, let's say, your CISO, how it's different from the expectations from your professor. These are two different expectations. And now, as a founder, there's still research happening. It's more like from the expectation of entrepreneurship, or let's say product standpoint. So it's a very like good, a well-rounded experience I have, and I really think it's something that a lot of people should be excited about getting into.
Yes, I think that your experience is very interesting because you have like taken the golden avenue, I would say. It's just the perfect curriculum. You started as work doing research in a lab very earlier on, and then you got to see uh, the other side of the business,
Yeah.
and it gave you more actions, I guess, and more the ability to really make stuff that have more impact, leveraging on your experience as a researcher. That's very interesting because it's really the ideal curriculum, I would say, and so I think I've read that you've published about 10 to 20 articles, right? So you have a huge background actually, because you spent not that much time in the academia, right?
I mean, I would say it's a little bit of time looking at the way the German academic institutions are structured. It's a bit longer than I think average in the US or even the UK, where people like within 2 3 years they're already out. But for me, it was super exciting, and I continue to kind of tap into that experience and use it even today. Yeah.
Yes, we can see that. Yes, it's interesting. All the stuff that you publish about chaos engineering, it dates back. You work on CrowdStrike. And also, I've seen an interesting article. All of them are probably interesting, but one specifically caught my eye, because my architect eye would say, the one when you say that we should reuse cloud patterns to secure on-prem applications, and to ease the transition towards the cloud. It was really, really, I think, forward-looking at the time. It
Yes.
was a
Yeah.
nice
Yeah.
paper.
Yeah. Absolutely. I want to shift focus to one of your publications, which was really interesting to me, and I think You researched and published something around, you mentioned already CMDB. And there is this idea, especially in cloud native infrastructure, of desired state, expected state, and then kind of trying to figure out the difference between these two states. And then that this idea is very powerful because you are using the APIs in between to kind of trying to reconcile. And it's kind of at the center of the resiliency of Kubernetes, like the whole magic happening in Kubernetes that people can rely on it. It's really based on this very simple idea of having, declaring a state, monitoring it, ensuring that the state is the way you want, and trying to reconcile kind of building. So can you talk a little bit about this idea from your perspective, especially from the idea of Azure, and how companies can kind of take advantage of these concepts, especially for security?
All right, that's really a great question. I think I'm going to take 30 minutes to answer, but no, I'm kidding. I will try to make it as short as possible.
Yeah.
So when I approached the cloud 10 years ago, we couldn't talk really about preventive security, which is more or less the answer in a nutshell to your question. I was really surprised because it was the state of the cloud 10 years ago was really detection oriented, and it was only partially detection oriented. AWS was leading the pack with detection. They had a few detection tools. Azure had almost nothing. And so for me, it was really, and Azure was looking for a way to challenge AWS, right? They were the challengers. They didn't have this 2-digit year-on-year growth, so maybe they had, but it was tiny. So I had the chance to be at the right time and at the right place to see that we had an opportunity to work with Microsoft on improving their security posture. And this is at the time where I tried to work on how we could enforce a secure state within Azure that AWS didn't have. And so we worked with Microsoft a lot about this concept of enforcing a state. And for that, what I like to do, I don't know you, and maybe it's different for everybody, but what is very successful with me is if I think like the machine. I like to think like a machine. Even if I don't know the machine, I try to investigate as much as possible, trying to imagine how the backends work. Then I project myself into the machine. And that's what I did for at that time. And this is where I thought that we could, in the admission pipeline of Azure, we could insert like hooks that would mutate the information on the fly to make it compliant to a desired state, and then to ensure that we would prevent evil from happening. And to prevent detection, forensic analysis, human activity, detection activity. The sooner you prevent the risk, the less the cost, I would say. So we discussed these ideas with our colleagues at Microsoft, and they liked the idea very much. And over the time, it became a product which is now called Azure Policy. And I'm very, very proud of what they did, because Azure Policy is just a monster of an engine. It has to connect to all resource providers, and there are a lot of providers in Azure. And of course, all the policy effects are not supported in all Azure providers. But still, it's very, very mighty. It's not, of course, 100%, as I said, 100% coverage, but the idea is here. And I'm very thankful to Microsoft because they didn't miss the important if you want to do preventive security. No matter the state you want to reach, no matter the channel, it can be Bicep, it can be ARM template, it can be Azure Portal, it can be Terraform, whatever. No matter the source of the mutation, it will be captured by policy and mutated if it's not compliant.
Wow. That's really, I mean, I didn't know this part of the history. And
now you know.
No, thank you so much for sharing that. That's really inspiring. I think for me, when I think we were actually looking at the early days of CSPM, and at that time there was nothing like CSPM. It was just, the cloud was there. Gartner was talking about human errors and how they will be the root cause of attacks. So we were actually looking at the idea of how do you even control, having a knowledge of the true state of the cloud. And there weren't detection, as you mentioned, a very similar experience. There weren't anything to detect threats, and even prevention. Things like S3 buckets really had no. They were just like more or less open. You can just get in there. And so we looked at different things. There was a very old paper they talked about. I think they talked about, if I remember, state transition analysis. It's a very old paper, but the idea, the guy was just using the whole idea of knowing a state, analyzing the state over time, and it was actually one of the early papers for intrusion detection system. But that kind of inspired me. I was like, well, you can actually take states and monitor over time, and by continuously comparing these states, you can figure out what's changed and maybe detect something that maybe what changed might be a malicious variable. And later I now saw that Kubernetes was also using it, but they weren't interested in security, but they were just interested in resiliency. So the idea was, well, if you can discover what changed and you can analyze it in real time, maybe comparing it with logs or whatever you can add to bring a form of context, you might actually just detect a problem which the system is not seeing. And that was really, really, really interesting. And I also saw that that's kind of what Terraform does in terms of reconciling, before it kind of deploys, but also it's a little bit limited there because it only knows Terraform. So anything that is not Terraform, it's not aware of it. And I think up to now, it's a very interesting way of doing in some kind of detection to know or to detect when there are malicious events in the cloud.
Yes, I think it's extremely powerful. You're right, and what you're touching on is, the power of logs and the power of analytics in the cloud.
Mm,
And I think that yes, this has been since the Kubernetes days. It has been magnified by the Resource Explorer APIs. Now you can
yeah,
query the CMDB in real time, and also the log analytics services. You can query logs in real time, and you can reconcile or
mm,
make join queries between
yeah,
the log world and the assets world using
yeah,
single queries, and that's very, very powerful. Yeah, you're right.
yeah,
It's something
yeah.
that we can do on premises. It's really novel, and it's something that has a lot of fertile ground for innovation and research. And I think, guys, that's what you're doing at Mitigant.
Yeah,
So
yeah, definitely. It's a lot of work to do, considering if you want to do it for all the cloud assets, all the services, and you have a huge cloud account which has many subscriptions. The level of, let's say, complexity can really, really increase. But I think that's not the major problem, because today we have huge databases that are doing all kind of very intelligent queries, and you could actually just use one of these existing solutions and do something really, really powerful. Yeah,
yes, and when the cloud started, there was a monopoly. The cloud providers were the only guys who were able to innovate in security, deal with
yeah,
vulnerabilities, and over time we've seen a huge shift. As you just mentioned, CSPM, you mentioned the work that you're doing in analyzing logs and the states. So
yeah.
over time, we've seen more and more vendors or third party bringing a lot of value to the cloud proposal, I would say. Yeah,
Yeah,
it has
absolutely.
changed a lot over the past decade.
Yeah, yeah, absolutely. I think one other area I think you did very interesting research, which we can actually just look at it, explore it a little bit, is in the area of reasoning, right? So And I think when it talks like more like this is more like formal reasoning, and this is also something that is not well discussed, right? So I know that one of the very popular technologies is by AWS, and they use it in S3 for kind of a doing some kind of formal reasoning behind to kind of analyze policies to understand when a policy is malicious or is overprivileged and on all of that. But it's not. I haven't seen other vendors. Maybe they use it behind the scenes. They don't talk about it. But I think I know Amazon AWS has talked about it very much and even published. And you also have you've talked about it. Can you discuss about the whole thing about this whole formal reasoning in topic, what's happening behind the scenes, how you've done it, and I think you also contributed some open source
Yes,
libraries.
yes, I did some stuff in that area. I think that we were talking about the power of automation and how we can save on cost and maybe increase the reach of security in all kinds of area of. And I think that uh, for me, automated reasoning is the future of cloud security. And I
Mm,
believe that AWS is also sharing this view. They have many engineers working on automated reasoning. What
mm,
basically automated reasoning does is that it allows you to prove things about the state of your cloud configuration so that
mm,
you are 100% sure that there are no glitches or no loopholes which you might have overlooked. And so you
mhm.
have 100% assurance that the scope, of course, it depends on the scope, but the scope that you are handling through automated reasoning is absolutely compliant with your golden rules. And
Mm,
only the cloud can do that because, for the reason that we mentioned earlier, we have an up-to-date CMDB, we have up-to-date sets. So my dream is to transform the cloud into a mathematical theorem. I want to collect the data to turn them into propositions that can be proven by a solver. And this way, there is no ambiguity. Imagine you have a regulator who is challenging you on maybe access control for your administrators, I don't know, or maybe network security rules. If you can
yeah.
give him a proof that you are compliant, a mathematical proof that you are compliant, I think it is just the top of well, it's just there's nothing to say about it, right? You cannot
Mm,
discuss that there is a loop, something wrong in the reasoning, except if the proof is wrong or maybe the assumptions are wrong. And so this is the power of automated reasoning. It can help human reviewers do things which are very time consuming.
mm,
Maybe humans are not perfect, we make all mistakes. A solver
yeah.
doesn't make mistakes. So yes, I did a few things in the field of automated reasoning, and well, one of the latest thing that I published only last week was Azure Magma, which is a way to use automated reasoning to check the compliance of your network security groups with maybe some golden rules that you have. And
Hmm.
I'm leveraging prior works from Microsoft Research on that,
Yeah.
which lets me use very powerful and fast algorithms to solve those problems and also make the proof understandable and explainable to human reviewers so that they can speed up the time it takes to validate maybe security group modifications, to understand
Yeah.
what has already been done, what remains to be done, stuff like that. So I'm very interested in this area because I think that customers should invest and vendors a lot more into this sector because it's going to be where we are going to find low-hanging fruits.
Yeah.
We have explored a lot of things now. We are exhausting the possibilities, and now I think the next stage will be yes to use the power of automation, which was not possible only a decade ago.
Mm. Right. Right. You said it before. I know you can talk about it for longer than that, but thanks for what you mentioned. And you actually pushed me into actually begin to already talk about the topic of AI, because I'm pretty much sure that a lot of people we contest if you say, well, automated reasoning is the future of cloud. To some people, the future is AI, right? So, what do you think? Do you think these two technologies can actually work together, or do you feel, because you mentioned automated reasoning gives you that transparency, that it makes it explainable, which is kind of the major issues around AI, because people, it's like a black box. People just believe, and in the end, we're also having issues around hallucination, and people are like, well, and this morning someone posted, I saw the post where someone was crying, and they're they're like, the AI is crying because it's not correct, and people are just believing it's actually providing correct responses. So what's your take on this, Christophe? These two.
I think it's a very it's a great question, Kennedy. I didn't expect it, and I think that's a key question, and we don't have the answer today. But many people, many scientists are not many, but more and more scientists are pushing that idea that you put forward, that maybe automatic reasoning can complement the action of generative AI. To help understand, or maybe to help drive and remove potential hallucinations or potential risks by formally double checking, let's say, what the AI is producing. This is a very powerful idea. It has a lot of potential because it's a very broad field of math at the moment. Terence Tao is a very renowned mathematician, who is interested into complementing generative AI and automated reasoning to help formally proving mathematical theorem, accelerating the proof theorems. But beyond that, there is a hope that we can balance or reduce hallucination by formally proving what the AI does, maybe by the use of ontologies. At the moment, we don't have the proper tools that would help us to prove or to disprove what an AI is producing. We need knowledge graphs. We need ontologies. We need to have a common dictionary between the world of theorem solvers and the world of generative AI. It's not 100% sure that actually, I don't believe that we will be able to deal with many use cases, because many use cases are going to be very difficult to prove with a solver. But I think there is a lot of potential for both technology to work in conjunction. Yeah. Very good question, and very interesting to follow, I think, in the next couple of years.
Yeah, I think it's going to be interesting, because what is happening now, from what I read, is now people are beginning to have these these agentic systems and multi-agents. So you have an agent who is more like a judge, who is like validating what other agents do, and then it gets to a lot of stack of validations, and I'm not sure how that works. There are other there are other. Yeah, go ahead.
No, you're right. There's a problem with that. We are talking about a stacking of technologies which are all the same in the end. It's like we had this debate a long time ago. Do we need to have two separate technologies of firewalls to protect our security, or our perimeter security? Here we have the same technology which is stacking. All the system hallucinate. There are many proofs circulating on the web that prompt injection is very hard to mitigate at the moment, because we simply don't know how to filter natural language like we sanitize our usual inputs. Yes, exactly. So at the moment, prompt injection is a reality, and it's very interesting, because we've seen, for example, this summer, a very nice proof of concept by Johan Reberger, who managed to inject some prompts into Microsoft Copilot to exfiltrate data out of Teams and out of emails from Office 364. And for that, he used special characters that's called ASCII smuggling. These are crafting special instructions into links that if you try, you could like compel a user to click on the link, and the link will send exfiltrated data with the
Mm,
use of Copilot. So I think that there is a great danger with AI
mm,
at the moment is that it's going too fast.
yeah,
We've seen a lot of great uses of AI. The AI is becoming multimodal now, and so many people have a tendency, especially the developers, that's where it's interesting, or the designer, they have a tendency
yeah,
to take shortcuts because they imagine that the AI behaves in the same way as we do, guys. So but in practice, it's very different, and AI remains a machine, right? So there
yeah,
are two worlds who are sharing a common set of information, which I would call, let's say, natural language or human information. We used to be between us humans. Now we have to account with AI, and there is an excellent and very good opportunity for research and innovation in this field because designers make shortcuts. They think that AI thinks like us. And
mm,
as I said, I will tease you a bit about the vulnerability that I found in some AI services, which rely exactly on what I said, actually. We shouldn't take AI for humans. And maybe
yeah,
there are ways to, I would say, uh, to leverage this so that we could confuse an AI, or we could kind of uh, from a given set of information in natural language, we can have different interpretation, whether it's interpreted by humans or AI.
yeah,
Uh, it's not prompt injection. It can be something else that can be prevented as usual, but it's easier to prevent than prompt injection. What I have in mind, but
yeah,
I think that if you want to do research in AI, you should work on multimodality, the new APIs, the new way we deal with information, the natural language information flow within the information system,
mm,
not only talking about just text and chat, but also documents, maybe videos, images, sounds, because we all deal now with AI through many modes. And those modes, we need to really think deep about what it means to interfere with an AI through different modes and how we can exploit the channels. That's very,
wow.
very, I think, prospective territory.
Wow, thank you so much for sharing this. And Crystal, I believe this vulnerability you just discussed, you already wrote something about it, right?
Yes, it's under discussion with the vendor which is impacted by this vulnerability. And I think that when I say vendor, it should be vendors actually, because the technology is the procedure is very generic. As long as
Wow.
we talk about how to deal with an AI, we can imagine that the procedure can be replicated in potentially many environments.
Yeah,
So we'll see what will be the outcome of this vulnerability. But the good news is that it's very easy to fix. But we can imagine of other procedures that might not be so easy to fix, and
yeah,
or you see.
yeah. Fingers crossed that they're able to like. I understand for now it's more like it has to be fixed, and maybe at some point in time, it's gonna be disclosed for
Yes, maybe very
more
shortly. It
people.
depends. It
Oh
could
yeah,
be
yeah,
very shortly
yeah.
disclosed. And if I publish anything, it will be in my newsletter.
Yeah. We'll keep our fingers, our eyes open for that release. I know you will definitely talk about it, and the vendors hopefully will also publicly talk about it so people get aware. Because there's something I've kind of known about these kinds of vulnerabilities. There is always when I think about vulnerabilities or weaknesses, there is the idea of 0 days, and it's like, well, it depends on who knew about it first. If it's a bad guy, he will begin to use it for his own malicious purposes, and or he will sell it out to someone who will buy it and use it. So that's happening completely in the dark world. If it's a good guy like you, then you kind of go to the vendors and tell them and talk about it. And so this is something that always goes around in my head when someone says, "Hey, I found this," I'm like, maybe someone else already found it and is using it maliciously, and this guys don't know. And it just gives them the notion that you have to, especially the vendors that are impacted, to quickly they have to quickly look around for a solution or a walk around and kind of make sure that it's not impacting people any longer. Yeah.
Yes,
All right.
exactly. It's not, yeah.
So I think we are getting to the top of the time. Um, Christophe, do you have let's say, just to wrap up the topic of research in cloud security, how it's important for companies. Um, can you like give like a summary, like what you found, the importance of cloud security for innovations, and maybe how companies should look at this very important topic in terms of their architecture or their planning or in their investments actually.
Yes, sure. Yes, I think that as part of the cloud shared responsibility model, security is not only, of course, the responsibility of the cloud provider, and the customers and the vendors have of their say. And we've seen more and more impactful contribution from from customers and vendors. It's not just a monopoly anymore. Now,
Yeah.
I think that personally, the drivers that helped me a lot to innovate in the field of security. There are three drivers. The first one, as I said, is think like a machine. Try to imagine how the machine will behave. And for that, I would recommend strongly all the blogs that the vulnerability researcher publish on the web. It gives a lot of insights that won't be usually accessible to us. And it can help a lot understand how the machine works. So it will help you project yourself into workflows, and it will help you to find caveats in those workflows. So the first point is think like a machine. The
Mm.
second point is leverage automation, I would say, for security, automated reasoning, the use of a CMDB, the normalization both by queries like resource explorer queries,
Yeah.
use them to find ground truth and maybe uh, reason like a mathematician about the ground truth. And the last thing is get prepared. Always get prepared. I think you, Kennedy, think the same. Preparation with chaos engineering. It's something that you advocate a lot. Getting
Yeah.
prepared means looking always deeply at all the vulnerabilities that show up in the cloud.
Yeah.
Always ask ourselves, is it something that could happen to me? Is there anything I can do? Or maybe it's something that I have to trust the cloud provider. But at least we always need to know and be 100% sure of what would the impact of a vulnerability disclosed by the researcher would be on my own workloads and my own environment. What are the lessons learned? Don't be
Yeah.
passive citizens and try to anticipate. Get ready. Imagine the impact. How can be improved, and this will also drive your research if you want to investigate in research. This is that you should align with the business, right? So if
Yeah.
you plan to have important business workloads, you have to get prepared to be hacked and know the consequences. Yeah, that's the drivers for research when you're customer, I believe.
Wow. Thank you so much, Chris. That was really good. Um, so
Thank you.
I think at this point in time, I believe that people in the audience will already have a bunch of questions. So we will basically switch over now to the question and answer phase of this research of this the research of this webinar. All right. So probably we can already stop recording, so everyone feels very